Welcome back. The next chapter, that is this organic chemistry of second year, starting with the haloalkanes and arenes. First question: halogen compounds may be classified on the basis of halogen attached to sp3, carbon included. The word carbon is missing. Allyl halide, allylic halide, okay, alkyl halide, allyl halide, benzylic halide, all the above. See, alkyl halide means Rx, that carbon is sp3. Allyl, what is meaning allyl? Carbon next to the double bond. Double bonded carbon is sp2, but next carbon is sp3, so that is also. And what is benzylic? This is a particular example of alkyl halide. This is a particular example of allyl halide, and this is benzylic halide. See, chlorine connected to sp3 carbon, chlorine connected to sp3 carbon, chlorine connected to sp3 carbon. So answer all of this. Best reagent, next is number 2, the best reagent to get the purest form of alkyl halide from alcohol. You know the reaction with the thionyl chloride, pyridine. Right. Alcohol when react with the SOCl2 in presence of pyridine. Okay. This oxygen combined with SO to form SO2, that is a gas. And this H combined with the Cl to form HCl, that is also gas. Since these two byproducts are gases, you are getting the pure form of RCl. That is why this is used to prepare pure form of RCl from alcohol. Darcy's method, that is the name. You find the answer. Question number 3. Role of anhydrous zinc chloride in the preparation of alkyl chloride from alcohol. See, I am also writing this equation: alcohol, anhydrous zinc chloride, HCl, that is a reagent. Alcohol plus HCl, okay, you are getting RCl plus H2O, and you are using anhydrous zinc chloride. What is the purpose of this anhydrous zinc chloride? Actually, this reaction is reversible. That means the products RCl and water join together to form ROH and HCl. Okay, to prevent this backward reaction, water should be removed. That removal of water is actually accompanied by anhydrous zinc chloride. Okay, actually zinc chloride is hydrous, means it is associated with water. So when we are removing the water, it becomes anhydrous. So such molecules have always a tendency to capture water. Okay, so here the advantage, anhydrous zinc chloride immediately absorb the water formed as byproduct, so that RCl remain alone. We can prevent the backward reaction. Okay, so reagent and dehydrating agent. Question number 4. What will be the order of the reactivity of alcohol towards halo acid? Means HCl, HBr, HX, the same. So here completely OH is removed. In the case of alcohol, suppose OH is removed, carbocation is actually formed. Okay, the actual step is this H plus will join to the lone pair to form ROH2 plus, and it is removing water to form R plus cation, carbocation. Formation of carbocation is the intermediate. Okay, and you know among carbocation, tertiary is more stable than secondary than primary. So order of the reactivity in this particular reaction, tertiary greater than secondary greater than primary. Clear? Suppose H alone is removed. Alcohol mainly undergo two types of reaction. In one type of reaction, H alone undergo cleavage, and that follows the order primary more than secondary more than tertiary, and that is the order of acidity also. And another type is detaching completely OH, and that follows the order tertiary greater than secondary greater than primary. So that is the chemistry behind it. Okay, so completely among primary alcohol, methyl alcohol is the lowest. So methyl alcohol is also included in the answer option. You find and tell me. Question number 4. Question number 5. Halo compound are best prepared from alcohol, but this method is not applicable for the preparation of. Halo compound is used for the preparation. Halo compounds are the best prepared from alcohol. This method is not applicable for the preparation of. Answer: alkyl halide benzylic halide, aryl halide, allylic halide. See, aryl halide cannot be prepared by that method because aryl halide benzene ring directly connected to OH, phenol. From phenol you are not able to prepare chlorobenzene or bromobenzene. So that is the answer. Question number 6, a reaction is given and that is the bond line formula and you are asked to find the products. See, 2-methyl butane. This compound reacted with the chlorine light. See, substitution happens. This molecule contains 3 types of carbon: primary, secondary, tertiary. I told you in the normal class, order of substitution depending on the nature of the carbon. Tertiary can be easily substituted, then secondary, then primary. Okay, so chlorine substitute here, that means the product formula. This will be the product formula. Okay, analyze answer option and tell me. Next, Rx plus NaI gives Ri and NaX, acetone medium. What is the name of the reaction? And that is called Finkelstein reaction. You know, Ri can be prepared by the halogen exchange reaction. Fluorides can be prepared by Schwarz reaction. Iodides can be prepared by Finkelstein reaction. So direct question. What is the intermolecular force among haloalkane? Dipole-dipole interaction. Okay, carbon to X bond is polarized. So dipole-dipole interaction is the main force. For the same alkyl group, boiling point of haloalkane decreases in the order. That means halogen different. Fluorine, chlorine, bromine, iodine. So fluoride lower, then chloride, then bromide, then iodide. R group is common. So depending on the nature of the halogen, boiling point increases. So RF lower boiling point, RCl again more, RBr still higher, Ri the maximum. Find the option and tell me as assignment. Question number 10. Haloalkanes are only very slightly soluble in water. The main reason because they are unable to form hydrogen bond with water. Okay. So first option, their intermolecular force is very strong. Haloalkanes form stronger bond with water. It's not forming. The new interaction between haloalkane and water molecule is weaker than original hydrogen bonds in water. That is right option. And more energy is released during the interaction. No. If more energy is released, it can break. So third option is right option. Question number 11. Which one of the following form propane nitrile as a major product? Propane nitrile means CH3CH2Cl. CH3CH2Cl is obtained by reacting CH3CH2Cl or Br with the KCl, alcoholic KCl. So answer is there, C2H5Br plus alcoholic KCl. Okay, you have to count the carbon of the cyanide group also. Okay, so that it become propane nitrile. CH3Br plus OH minus gives CH3OH Br. This reaction follows SN2 mechanism. Rate of the reaction depends on. See, SN1, SN2, you know the difference. SN1 rate determining step contain only Rx. Okay, SN2, Rx and nucleophile, OH minus, both are controlling the rate. Here it is SN2 means CH3Br and OH minus. Okay, first option. Order of the reactivity of alkyl halide, question number 13. Order of the reactivity of alkyl halide towards nucleophilic substitution reaction with the same alkyl group. So if the alkyl group is same, only the difference in halogen, so bond length is the deciding factor. So Ri is the longer bond that can be easily broken. Rf is the shorter bond that is very difficult to break. So from Rf to Ri, reactivity increases. Okay, or from Ri to Rf, reactivity decreases. Find the option. Question number 14. The stereoisomers related to each other as non-superimposable mirror images are called as enantiomers. What will be the question number 15? What will be the major product formed? Okay, whenever 2-bromobutane is treated with the alcoholic KOH. 2-bromobutane alcoholic KOH is dehydrohalogenating agent. So 2-butane. This is 2-bromobutane, CH3, CHBr, CH2, CH3, alcoholic KOH, you know. Alcoholic KOH is a dehydrohalogenating agent. So alpha, beta, beta. Okay, this is gamma. 2 beta positions are available. So according to Saitsev rule, most substituted alkene is the product. So CH3, CH double bond, CH single bond, CH3, 2-butene. Agree? It's a direct one. Next, question number 16. CH3CH2Br Mg dry either A. Water, B. What is B? CH3CH2Br. CH3CH2Br magnesium ether. It's a Grignard reagent formation. CH3CH2MgBr is the product formed. That is A. Agree. And water means HOH. So alkyl part of the Grignard reagent combined with replaceable hydrogen to form ethane. Serivitnov method. That is the name of the reaction. Grignard reagent when treated with a compound containing replaceable hydrogen, that replaceable hydrogen joined with the alkyl part of the Grignard reagent to form an alkane. Agree. That is called as Serivitnov method. Hey, instead of water you can use an alcohol, you can use ammonia, you can use acetylene, okay, you can use carboxylic acid, benzoic acid, acetic acid, anything. The condition that molecule should contain a replaceable H, that's all. Okay. Question number 17. Aryl halides are extremely less reactive compared to a haloalkane. There are 3 or 4 reasons given in NCERT. First, resonance effect. Second, sp2 hybridization of the carbon of aryl halide. After removing X- from haloarene, phenyl cation is formed, that is highly unstable. So all these reasons support aryl halides are less reactive towards nucleophilic substitution. Which of the following statement is correct? Dichloromethane is used as a solvent, paint remover, correct. Chloroform get oxidized in presence of light to form phosgene, correct. Dichlorofluorocarbon, the chlorofluorocarbon compound of methane or ethane, they are collectively called as freon. Everything is correct. Question number 19. Which of the following halide does not get hydrolyzed easily? Okay, does not get easily hydrolyzed means that chlorine or halogen should be connected to sp2 carbon. If it is sp3 carbon, easy to hydrolyze. So first option is answer, vinyl chloride. Vinyl means double bonded carbon. It is sp2, so it is difficult to break. Second is methyl chloride, third is ethyl chloride, fourth is isopropyl chloride. Everything haloalkane in which halogen is connected to sp3 carbon. Okay, so sp2, if it is benzene, also cannot possible. Question number 20. Which of the following, the reaction of toluene with the chlorine in presence of sunlight. Toluene in presence of sunlight. Okay, gives predominantly. In presence of sunlight, in presence of AlCl3. Let us write. It's a comparison. I discussed the same type of question in hydrocarbon chapter also. Hydrocarbon. Okay. See, toluene. This is toluene. And I am proposing 2 conditions. One is chlorine, light, HNE. One is here absence of halogen carrier you can write, but here AlCl3, or you can write dark, no light. Chlorine AlCl3 means substitution. Okay, substitution in the ring. Friedel-Crafts reaction, you know, that type of reaction. Chlorine in presence of AlCl3, substitution happens in the ring. So substitution in the ring means that is decided by the methyl group. You know, methyl group is a plus M group and that is an ortho-para direct also. So here the compound formed are ortho-chlorotoluene and para-chlorotoluene. But in presence of light, the reaction happens here, CH2Cl, it will not stop, CHCl2, and finally you are getting CCl3. So these are the products formed when chlorine in presence of light. Here the condition, chlorine in presence of sunlight. So predominantly producing benzyl chloride, benzyl chloride, benzotrichloride. Okay, benzyl chloride, second option is there. Got idea? Okay, benzoyl chloride is another. C6H5COCl is called benzoyl chloride. It is benzyl, ZYL. Okay. So these are the questions from haloalkanes and haloarene. Study it. It's a continuation. Next chapter is based on alcohol phenol ether is based on the present chapter. Okay, so study organic chemistry in a sequential way. That means starts from hydrocarbon itself or from the basic chapter itself. Okay, it will be in a structure. Okay, one connected with another, that one connected with the third one, like that. Okay, so proceed confidently. That's all today. Okay, study well. Write assignment and submit in the common WhatsApp group. Great. No second.